Alright, we're going to look at two of the exponential rules and how to work with exponents. This is typically a topic that a lot of people struggle with, just because there are quite a few rules and the combinations of all of them mixed together can be very tricky. These are the two basic ones. When you're multiplying two numbers together that have exponents, m and n, they could be any number, negatives, positives, whatever. The result is simply adding the two exponents together. And for the division, the opposite of the multiplication, when we're dividing two numbers with exponents m and n, then you would subtract them. So let's just take a look at both of these cases. And let's first start with the addition rule. And so let's just use a simple example with numbers. So 3 to the 3 squared times 3 to the 8. And so using our rule here is that we should have 3 to the 10. And really what's going on, and some of the mistakes that happen, is a lot of people will multiply the two bases together and get 9. But we already are multiplying when we're adding these exponents. And one way to visualize what's going on here is, well, what is 3 squared? 3 squared is 3 times 3. And then what is 3 to the 8? 3 to the 8 is 3 times 3 times 3 times 3, 3 times 3. Let me make sure I got all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that's what the equivalent of 3 squared times 3 to the 8 is. It's just simply 3 times 3. Here's your first part. And then there's 8 more for the second part. And then adding all the 3's together, we get 3 to the 10. You can do this with variables as well. X to the 3 times x to the 6. And typically people have a little better success on these because there's really nothing to multiply together. The x times x is simply just your x, and then 9. Okay, now let's go to the division. And so let's use our 3 again. 3 to the 8 divided by 3 squared. And what that would be would be 3, still the same base, and then 8 minus 2, which would be 3 to the 6. And we could do this again, expanded. 3 times 3 times 3, that's a little bit hard to read. 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6, 7, 8 divided by 3 times 3. And when we're dividing, you can cancel out any multiplications that are the same. So I could cancel out sort of like that. And then what do we have left over? We have 6 3's. Now, with division, what happens if we have the reverse of this? Meaning the 3 squared is on top and the 3 to the 8 is on bottom. And really what we would have is 3 squared minus the 8. And well, what does that give you? That gives you the negative exponent. And I'll have a whole video over negative exponents. But what does that mean? Well, it's better to, again, look at the expanded form, because now the 3's are on the bottom and then the 2 are on top. Well, what would cancel out? Well, all the top cancels out because there's here and here. And well, what does that mean? That's going to be a 1 left on the top, and then the 3 to the 6. And so we would have this relationship with the negative exponent, and notice that the negative exponent really just shoves something down into the bottom of a fraction. And like I said, we'll talk more about this in a whole nother video. Now, what I recommend is not really showing this step here. Instead, when we do the division, we know we have to subtract, and where is the bigger number? The bigger number, of course, is on the bottom, and so my 3 to the 6 answer needs to be also on the bottom. And that way it eliminates any confusion with the negative exponents, and simply just assigns where it's going to be right from the start, because I know it's got to be on the bottom because that's where the bigger number is. Okay, and so next time we'll work on multiplying exponents, and then talk about more about the dividing negative numbers in the exponent. Thank you.